Hello and welcome to another programming video. I talked to my friend and she said that going through the script isn't really what would be helping her, because especially after seeing that the script is just crap. So instead we were talking about her homework assignments, and she was doing a calculator and she was wondering how I basically would do a calculator. So they're using forms as a technology. So let's go ahead and make a new project. We need to find a forms project. I keep forgetting. Oh, this is C++. No, she's doing C#. Other languages, C#. I guess, would it be Windows? Windows Forms application, yeah. Okay. And just call it calculator forms. Okay. So it's generating an empty forms project, and if I start that, I should see forms right away. I think we're doing this, yeah, there it is. There's the window. Let's do this kind of, I guess, 2 times. Once the quick and dirty way, so what you would do in a prototype that's meant to be thrown away. Prototypes, usually these things are buggy and it absolutely makes no sense making this calculator. But it's a program exercise. So if you get some inspiration in here, here's a calculator. It has buttons, +5 equals 17. Now, one thing that you could do is calculate 2 plus 1 times 3. So the result should be 5. 2 plus 1 times 3 equals 5. So this one is actually, it's caching the whole math. 2 plus 1. Where's times 3. You can see it up here, where it's actually caching the formula. I don't think that they were doing that. They were doing like only simple operations, because building up an application that does that requires you to build up like the whole node map of math essentially, and then have math be resolved, because you need to have an order of properties of how are they called? Just quickly, operators, order of operators, and let's go with the ANSI C list, because they have ANSI C has a pretty good representation of that. Okay, so here, order of operators. These one go first. If you have brackets, they go first. And you need to know what your operators are and how to resolve them. So you need to build up like a tree of things and how they connect. For instance, with our multiplication, the multiplication would be the top node, and you kind of have to resolve the, other way around. The plus would be the top node because it's the one that's executed last, and then the multiplication one would be somewhere closer to the leaves, so it would be constant plus the result of multiplication result of constant times constant. And then, oh, I'm just noticing that I still have this filter in here. Filters. Yeah, this works, right? Yay. Okay, so let's go. Actually, why I'm not, I have Paint. So yeah, so your result will have like a node tree that looks like that. With a multiplication in here, an addition up here, the number, what was it? 2, right? 2 down here, the number 1 in here, and the number 3 in here. And then you have to resolve it from the leaves first. So you need to draw a 2 big circle. You have to resolve this one, so the result is 3. And then you resolve this one, the result is 5. That's how you math. So we're going to do improper math. So our calculator will just always only work on 2 operators. And we want to present that in our UI. Let's go ahead and just drop in some, I think it was tools, right? Yeah, you cannot see the overlays, so I just have to describe. I clicked on view in a desperate attempt to find the toolbox. Yeah, there it is, toolbox. Common controls. So we're gonna have a label. And let's call this, no, I double clicked. Okay. Let's go into the properties of the label and remove the action that I just added by double clicking accidentally. Behavior. Guess it would be an event, right? Click, label, click. Okay. Removes. And it also updated the background thingy. Okay, so the text actually, can I search? Does this thing support any form of searching? Because what I'm looking for is the text now. F2. Yeah, I do see the properties already. There has to be a search box, right? Alphabetical. Categorize, go alphabetical, because I'm looking for text. Text changed. Okay, maybe I'm looking for content. It says label 1 now, and I can't see data bindings. Nah, that's not it. Where would you hide if you were a text? Name? It can't be the name. Nah, it's not the name. Okay. Label left. It is text. Why did it not show up earlier? So the text is left operator, left operand. Just left. Don't have that much text anyways. And then we're going to have another label. Let's grab another label in here. And let's call that one right. Okay, we're going to need 3 text boxes. Maybe even have a drop down. Okay, let's go give it an output. Label, and let's call this one result. Okay. Label result. We will never use these labels. I already started, so let's go. Label right. Yeah. Okay, this is just labeling on the UI, and now we need text boxes to put something in there. Let's go with simple text boxes. Text box. Like that. Grab another text box. For the operator. And we're doing this very restrictive UI because we're going to implement a crappy calculator. So we cannot, if we offer anything more than that, we are lying. I'm going to have a button. It's our calculate button. Label of that one is pretty easy. Should have text in there. Let's have just an equal sign and then an output text box. Okay. Right. Let's label these text boxes. Maybe we can use that later. Oh no, I switched something. I tried to scroll. And this right here, so yeah, label, let's go text left, text OP, and text right. Yeah, then we have the button equal. And it should be lowercase now that I think about it, because it's being translated into auto-generated names, and they should all start lowercase. But we started uppercase, so text result. Okay, I think that's all we have to do. If someone clicks on the button equal click, okay, once we have a button equal click, if sender is button, that is C#4, 6, I think. Okay, so it can't do it. That is called, keep forgetting. There's a name for this type of thing. Okay, var b equals sender as button. Actually, we're not interested. We're not interested in the button. There's nothing we need from the button. So we're going to read double integers. We don't know. Double L left equals text left dot text, and that is double try parse out var, actually I can't do that. That's also C#6 is so much better than C#4. That's just not supported in Windows Forms. So we need to left. Okay, so double left equals 0.0 and out left. So we guarantee to have a left. Going to do the same for right. Text left, text right. Okay, now we have left and right, and we have an information whether parsing was okay. We assume that it's okay, and we dump all the okays in there. Okay, so then we grab the operator, which is a single character operator. Let's just go with OP. is nothing. Okay, and okay, and equals operator parse text text op.text. Out op. This function obviously does not exist. So let's make that. We have to guarantee to give something back in the out variable, so we need to initialize it. So we might as well start with an error case. If there's an error, that's what we give back, like nothing. If text dot length is not exactly 1, return false. So that's an error case. Then we have possible operators. Let's have a new array and dump all the possible operators in there. So we're going to go for simple ones like plus, minus, multiplication, and division. And if possible contains text length, text we know it's exactly 0, so it's guaranteed to have this element. And if it does not contain, then we're going to return it, return false. And in any other case, we basically return text 0, because now we know text 0 is in our possible range. Oh, sorry, OP is text 0, and we return true because parsing was okay. Okay, so text 0 is in the possible range. We check that with our possible characters. This one gives us two types of information. Gives us back the selected operator, and it gives us back whether or not something was true. Okay, so we have all our inputs. We parse that. If okay, well, if not okay, that's when we are bored, right? If not okay, like what does the error look like? Text result, I think we called it. Text result dot text equals error. We're not very specific about our error, and then we return because we have to end this now. Okay, so the next step. Now we know everything's okay. We could just if else chain that, and maybe let's start with that. So we want to have the text result dot text equals calculate left OP right. Okay, so and that's not something that should make you immediately suspicious. We wrote all of these, kind of have to rewrite them. So something is up, and we're going to do something, we're going to make this into something different in a second. But I know that my friend specifically mentioned that they were supposed to learn if else instructions. So we're going to use if else. If that equals OP, return left plus right. Actually, the lowercase. Rigth. Ah, that's it. Right. Okay, and this is also right, not rigth. Righty right. So, and that's actually not the result we want to string of that. Which, because these are simple value types, actually gives us the string that we want. If it's minus, do the minus. And because we're returning, we're guaranteed to end this. Okay. If it is division, you return that. So let's go multiply, divide. And the final one, like if it's none of those, it's still error. Let's go call this calc error. And this is parse error. Should we have a space? Let's not have a space. Okay. And there you have it. That's a calculator right there. So 4 plus 5 is 9. If we multiply this, it would be 20. We cannot reach the calc error because our parsing is set up correctly. That's more for the future. If we modify something and we don't exactly do it right in the parse error. 4.6 actually goes 230. Yeah, he ignores the point. (23) Because this is language specific. So the parsing is language specific, and it depends on your Windows version and kind of what the local setup is, what he thinks the number is. So we could try to display that as well. Now this gives a parse error, which is fine. Right. So does an operation that we did not implement, also a parse error. Okay. Yeah. At that point, since this is a prototype, we would have to discuss if 4.6 plus 5, should this be 69, or should the result be 11.4? We really need to ask the customer, or should this result be parse error? We're not accepting that. Are these integer numbers? So is it even allowed to have floating point numbers in here? So let's do something else. Obviously, we could have gone if we wanted to do something excessive with these FLs. We could. There's a thing of only having one return parameter, and it makes sense. So we could have string red equals red like return, and initialize with the failure condition, and then go red equals on every one of those. Now this would still work because we can only hit one of these. We can also go else if it were more complicated, and then in any case always return red, right? So that has the same behavior. This exactly did nothing. So 1 plus 3, whoops, And it's a bit annoying to use right now, but that's because we wanted this to be really restrictive. Okay. So what else could we do? You could argue that you want to use switch and have a switch statement. Actually switch on OP. Go case plus with break, and then kind of have that. So switch statements also, if you're doing what we're doing here, it looks like switch statement is an improvement, but I'll show you an issue that comes up. We don't need a default case right here. It's usually a good idea to have a default case. So let's go, not decimal, default. Default case red equals, and that's what we do with calc arrow basically. So we can remove it from the initialization and break. Okay, right. So it looks like a slight improvement. Let me show you what happens if we introduce another calculation. Let's go with modulo. So modulo is typically this percentage sign. So we have to add it to this list now, down here, so we can parse it. We're allowed to parse it. And now we need to add it up here as well. Add the character that we designated. I just introduced a bug. This is where testing comes in, by the way. Okay, I don't think that this does anything. Really? I thought we would have gone math.modulo or something. Let's go 5 mod 4, that is 1. 9 mod 4 is 1. 10 mod 4 is 2. Fine, it is working. Okay, so that's apparently that's an operator. Not entirely surprising. Okay, so what we did here is touch the system in 2 locations, and that's the real problem with both the switch case and if else. So that's the real problem. What we actually have is this setup here, where we have an operator, a left and a right, and how this operator is used. That's basically what we have. So what we want to do, a function, you can see how calculate this function. We could have a function that says add, right? And left and right, and gives out the string. So return add, and this is very close to just what an operator is. This is a binary operator, and they're different kind. They're trinary operators. Let's go into operators real quick. So you have one like plus, and that has a, so the operator plus, I keep forgetting how to write this, operator plus, I think the next comes the return value. No, it doesn't make sense, right? It has to be left. It could be, let's just go int, and then something is wrong. This is written differently. I'm mixing up my languages. But this is a binary operator. Let's make it concrete. Like 4 plus 5. Yeah, I'm thinking about if I should talk about notations. There is a different operator, like a trinary operator, and that will be some bool, question mark. If it's true, then 4, otherwise 7. So this thing has three variable parts: the bool, the 4, and the 7. And you have kind of 3 spots where you can feed something in. you can see how add only has two spots where you can feed something in the left side and the right side. And it's not necessarily the left and the right side. I could write this differently. I could write, and it's easier to read actually, I could write 5, 4, 7. Now that's called a post notation. And the reason why that is easier to read is because you can go, the exact multiplication problem that we had could go multiply 1, 3. And now if you want to calculate plus, you know that you have to calculate that one first. And structuring that way makes it easier to read. But that's actually not what I wanted to talk about. So we have this addition, and it's basically doing this right here, right? So you can see how I could call add here. And now we kind of have this post notation that I was talking about. You can say add left, right. That's the same. It's just calling the other function, right? Functions themselves can also be variables. There's a thing like, yeah, you could just make a lambda expression, but you can also just use this add method as a function. So you can write function, and yeah, I don't know if you know that. Function string and actually double. So this is a generic thing. My func equals add. Okay, I'm saving my add function into this function. This is kind of a wrapper so that you can use that like a variable. And now my func can be used the same way that add could be used. You see that? There are 3 types of these, and if you hover over it, and you cannot see my overlay, but if you hover over the func thing, you can see that it is a delegate, and you have like a bunch of, there are a number of overloads, and they're literally exactly overloads. So there's nothing super dynamic. You just wrote the thing 10 times or something. And it has like only return value without any parameters. 1 parameter and a return value, 2 parameters and a return value. That's func. If you don't want a return value, you use action. So action integer would be something that takes an integer and has the return value void. So for void, you don't use func because you can't use it like in an out parameter. That's not possible because void isn't a type. So you can't use it in the generic type system. So that's why they have to come up with another one. And specifically, if your return value is a bool, then you could use func, but it's more speaking if you use predicate. That's besides the point though. So these 3 are just useful to know and come in handy occasionally. So my func, let's go for one step further. My func 2. You can use what's called a lambda expression, and you basically, so the lambda expression works, you take these brackets up here, the one where it says left and double. So I'm rewriting this now as a lambda expression. Take left and right as doubles. The types are already known because of the func, so you don't really need to know the types. Left and doubles, and then you go arrow and say, okay, here's my implementation of that. And you take these brackets, and these brackets are the implementation of that, right? So you've written the same thing, and it's a little bit red right now, don't panic, but you've written the same thing. You left out the name. You have the parameter list, and that's here, and you have the body. Now the type of string is already known because it's in here, right? This thing produces a string, it returns a string, so you don't exactly have to write it for the computer to know it, because it's literally, you just has to look what's the type of the return value. So that's why you don't need the return type. And the input types are not that critical for him to know because they're out here as well. So they're kind of in the usage of that lambda. Whoever uses the lambda defines these types. So you can remove that double from that list, and now it stops being read. Oh no, it doesn't. Okay. Now, because the whole thing is, we're assigning that to a variable, he's kind of weird about what we wanted to assign. So in order to help him, we just add these brackets. What? Oh, the local ones. I named them the same way as the local ones. So let's rename them, call it L, and call the other one R. All right. Actually, don't I need these brackets? Yeah, sometimes he's confused and I'm adding brackets, but I actually did not need these brackets here. Okay, so now this myfunc2 does the same thing as the myfunc. So I can just add it, right? And now I don't need the add function anymore because I literally just wrote the add function here. Let's see if that still works. It will, just to show you. 2 plus 3, 5. Nice. So, and it used this one. When he called myfunc, he went to this variable, passed in L left and right as L and R, executed whatever was written here, L plus R to string, and returned that. So that's my add function. Why should it call it func? It could just call it add. I can make one of these for each one. So then we have a sub, we have a div, we have a mul, and we have a modulo, mod. So instead of calling that, I can just go, and I'm still reworking this. I don't know, maybe you can already see where this is going to end up. Also, I just realized that we did not handle the error case divide by 0. That's a useful error case to check out. Add sub mul div and mod. Okay. So add sub, mul, div, and mod. Now all of our functions are supported. Actually, if I go and divide, I can check if r equals 0, return div 0. Else return. I'm one-lining these now. Yeah. Okay, so now we checked for 0 as well. Okay, so we're just assigning this function, this plus belongs to add, this minus belongs to sub, this multiply belongs to mul. Multiply will never belong to any other function, so we're kind of guaranteed that this is kind of a key. And there's a thing in the amount of objects out there that are made to help the average programmer. There's a thing called a dictionary where we can just look up stuff. So you look up the plus and you get something back. Well, that's something that we need is the function that we want to execute. So you could slam that in a dictionary. So we have a dictionary of character on the one hand, that's our key. Then the value that we want to look up is of this type, this func type, right? Execdict equals. We have a new dictionary, and the easiest way to initialize is just with curly brackets, and each element has a curly bracket set inside with a comma separating the key, that goes in here, from the value. Okay, so what's our key? Our key, for example, would be plus, and our value would be add. And we kind of need, I think, 5 of these. Now keys cannot overlap. You cannot add the same key twice. That would throw, actually. So the dictionary, if it realizes that someone's trying to add another key, the same key again, it would throw. There's a difference between adding a key and overriding a key, but those are details that are not important for what we're doing here right now. So, but instead of writing add, I can just use this function here, because it doesn't matter where I assign it, right? So all of these functions, they kind of all go in here. Now the line doesn't end here, so I need to remove these semicolons that are at the end of each of these lines. Okay, so we initialize the whole dictionary. We don't need these functions anymore. We move them. We move their definition into this dictionary. So how does this look up? Like switching OP, execution dict, and you could just go OP. And then you looked up the function, the return value that you get from it is the value, which is a function. So now, since it is a function, we can just call that function with the normal brackets. So we use the normal brackets, go left, right. Return. So what did we do? We handled looking up plus, because that's in there. We handled looking up minus, multiply, divide, and we handled modulo. Hey, there's an error case. What's that error case? Well, the key is not in the dictionary. That's a problem. Right now, if OP is not in the dictionary, we get an exception. So we want to check that out. execdict.contains key, very convenient function, OP. And let's use a trinary operator since we're doing operators. So that's a Boolean that we get. Does it contain it? Yeah, it does. So then we do the execute. In another case, we return the calc error. All right. And now we have to actually return that. Okay. So how do we add? We still did not solve adding another operator. Which operators are still there that can be added? Trying to find one. Oh, we can use power. So if we add the power operator now, we have to add it here and we have to add it here. So really the calculation is coupled to the data that we need in order to execute the calculation. So these two things are coupled, but they don't have to be. So we just move that into the outer scope. Let's move that actually inside of the form up here. And we can check out which keys exist. Instead of possible, we use, how do we call the thing? Execdict, execution dictionary. I'm awesome at naming. So instead of, well, all of the things that are in the execution dictionary are possible. So instead of possible, let's remove that. We use contains key again. Dot contains key. Text text 0. Right. And we were checking if it does not contain that. So if it does not contain the key, we can't parse it. It's not possible for us. So really now these two functions depend on the same databases, and this is the point that we had to reach in order to make the following possible. If I add another key, I need to touch the system. If I add anything, I only need to touch the system in one space, in one place. So if I add this here, and let's use a caret as the symbol, I just have to add it here. Is math.power. mathpow, yeah, left, right. ToString. Okay, so if I now execute that and I ask myself, what is 2 to the power of 2? I can calculate that. 2 to the power of 4, I can calculate that. And I only added it in one place. So we kind of evoluted a little bit through how to write a calculator. Small evolution. I hope this was at the very minimum fun. We could just dwell on this for a brief moment. And yeah, there it is, a simple calculator. I hope this was fun. I was sure it was fun recording it. And yeah, see you on Friday, one of the future Fridays, I guess. Bye.